Welcome to the channel, everyone. In today's video, we're going to be tackling a topic that's super important for any Python developer. Whether you're just starting out or you've been coding for a while, virtual environments. Now, you might be wondering, what is a virtual environment and why should I care? Well, put simply, a virtual environment is like a self-contained box where you can install all the specific packages and dependencies your Python project needs without messing with your global Python installation. This might seem like a small detail, but trust me, using virtual environments can save you a ton of headaches down the road, especially as you start working on more complex projects. So let's dive in and explore the technical reasons why you should be using virtual environments for your Python projects. Okay, let's start by talking about dependency hell. Imagine you're working on two different Python projects. One is a web app using the latest version of Django, and the other is a data science project that requires an older version of Pandas. Without virtual environments, both projects would share the same global installation of Python and its packages. This means if you install a package for one project, it could potentially break the other project if they require different versions. Virtual environments solve this problem by creating isolated spaces for each project. Each virtual environment has its own site packages directory, which is where Python stores the packages installed for that specific environment. So your Django project can have its own version of Django and all its dependencies, while your data science project has its own separate set of packages. Another great thing about virtual environments is that they give you fine-grained control over which Python interpreter you use for each project. This is particularly useful if you need to work with different versions of Python. Let's say you have Python 3.7 and 3.9 installed on your system. You can create one virtual environment that uses Python 3.7 for an older project, and another virtual environment that uses Python 3.9 for a newer project. This way, you don't have to worry about compatibility issues between different Python versions, and you can ensure that each project is running in the environment it was designed for. Virtual environments also excel at managing environment variables specific to your projects. Environment variables are like special settings that can be accessed by your Python code, and they're often used to store sensitive information like API keys, database credentials, or secret tokens. Now, you wouldn't want to hard code these sensitive details directly into your code, right? That's a huge security risk. Instead, you can store them as environment variables within your virtual environment. This way, the environment variables are only accessible within that specific project's environment, keeping your sensitive information secure and preventing accidental leaks. When you're developing a Python application, you want to make sure that it runs smoothly, not only on your local machine, but also when you deploy it to a production server. This is where the concept of development and production parity comes in. Ideally, you want your development environment to mirror your production environment as closely as possible. Virtual environments help you achieve this by allowing you to define the exact same Python interpreter, version, packages, and dependencies in both environments. By creating a virtual environment that closely matches your production setup, you can catch potential issues early on during development rather than having them pop up unexpectedly when you deploy your application. The Python ecosystem is full of amazing tools that can help you write better code, manage dependencies, and test your applications. And guess what? Most of these tools are designed to work seamlessly with virtual environments. For example, the package installer pip, which you'll be using all the time, is environment aware. This means when you're inside a virtual environment and you use pip to install a package, it installs the package only within that specific environment. Similarly, testing frameworks like PyTest can be configured to run your tests within a virtual environment, ensuring that your tests are using the correct versions of all the required packages. And have you ever joined a new project and spent hours trying to set up your development environment just to get the code running? It can be incredibly frustrating, right? Well, virtual environments, along with a file called requirements.txt, can make this process a breeze. The requirements.txt file essentially lists all the packages and their specific versions that are needed for your project. You can generate this file easily using the command pip freeze. Requirements.txt. Now, when someone else wants to work on your project, they can simply create a new virtual environment and run pip install requirements.txt. This will automatically install all the necessary packages with the correct versions, ensuring everyone is on the same page. Let's say you're curious about trying out a new Python library or experimenting with a different version of a package. Without virtual environments, you'd have to install it globally, potentially affecting all your other projects. Virtual environments give you the freedom to experiment without the risk. You can create a separate environment specifically for your experiment, install whatever you need, and if things don't work out, you can simply delete the environment without affecting your other projects. This allows you to be more adventurous with your Python development, trying out new things and exploring different possibilities without the fear of breaking your existing code base. Most modern integrated development environments, IDEs, have excellent support for virtual environments, making your life as a developer even easier. For example, in popular IDEs like VS Code or PyCharm, you can easily create, activate, and manage virtual environments directly from within the IDE. You can also select the specific virtual environment you want to use for each project and even see which packages are installed within that environment. This tight integration between virtual environments and IDEs streamlines your workflow, allowing you to focus on writing code rather than fiddling with environment settings. And there you have it. We've covered 8 compelling technical reasons why you should be using virtual environments for your Python projects. From avoiding dependency conflicts to keeping your sensitive information secure, virtual environments offer numerous benefits that can significantly improve your development workflow. Remember, using virtual environments is a best practice in the Python world. It not only helps you write cleaner and more maintainable code, but also saves you from potential headaches down the road, especially as your projects grow in complexity. So if you haven't already, I highly encourage you to start using virtual environments for all your Python projects. Your future self will thank you. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more Python tips and tutorials. See you next time.